Hello, my name is Christopher Songer, and I am doing my final project on how does aging affect the brain. Here I have a picture of a normal brain that moves on to a mild cognitive impairment, and then overall Alzheimer's disease that shows the degradation of the brain. So, what is actually happening to our brain as we age? We are going to see a brain volume shrink overall. As we age, our brains are going to shrink over time, especially in certain regions that are important for memory, decision making, and emotional regulation. The prefrontal cortex and the hippocampus are among the first to show this overall shrinkage. And in this shrinkage, what I mean is we're going to see loss of gray matter and white matter. So with the gray matter, we're going to see a loss, which the gray matter itself is containing the cell bodies of our neurons. And as that goes, we decrease with age. This contributes to a decline in our cognitive abilities as gray matter is involved in processing information and controlling muscle movement. And we will also see a loss of white matter. And as our white matter becomes damaged or degraded, you'll see um, an increase in the mean diffusivity. As I talk about in the next slide, it's a measure of the mobility of water molecules in the brain, typically indicating less efficient white matter. And damage to this white matter is also associated with slower cognitive processing, and disruptions in the white matter pathways can lead to cognitive decline. We see this because white matter is going to be the myelination of our neurons and everything. So as we're seeing that degrade, we're seeing less effective signals being sent. This also leads us to a reduction in synaptic connections. Neurons in the brain become less connected to one another over time, and the synapses may weaken. This reduction in connectivity can lead to slower thinking and memory processing. This can have a lot of implications for reaction time, memory, just overall, we're seeing this separation. And like like in the topic of neuroplasticity, use it or lose it, as they start getting weaker, we're using them less and less, and it's just further degrading those. And down here, I have a picture of a brain at 42 years old and at 82, and you can see just overall the overall shrinkage and the demyelization as we're losing this white matter. You're seeing this big gap form in the middle. So what happens to our brain as we age continued? You're going to experience slower processing speeds. Aging often leads to a slower reaction time and processing speed. This is partly because of the brain's ability to transmit electrical signals between neurons and how they become less efficient. This decline in white matter integrity is often linked to the slower processing speeds. As I said, as you're losing that myelination, we're losing that connect or that conductivity, so it's just gonna be slower and it's gonna be more scattered. As well as this, we're going to see a major cognitive decline as we age. We will experience difficulties with certain cognitive tasks like memory. Short-term memory and the ability to form new memories is definitely going to decline, particularly because of the reduced hippocampal function. It's no longer as effective at processing that memory and sorting it. So you're going to see a lot of that just disappear entirely. And you'll also see a lapse in attention and focus. Maintaining attention and focus on tasks may become more difficult, especially for older individuals. They may take longer to switch between tasks or concentrate for extended periods. Sorry. Executive functions, cognitive functions such as decision making, planning, and problem solving, which rely heavily on the prefrontal cortex that we said is going to see that shrinkage very quickly, is going to weaken over time, making it harder and harder to plan and execute tasks efficiently. And all this comes back to play with neuroplasticity. While the brain's plasticity is decreasing over time, it doesn't disappear. We are still able to make these new neural pathways and grow, but this process is very slow and may require much more effort. And the mental and physical activity can help promote this neuroplasticity, as I talk about later. And you see a major neurotransmitter decline along with the synaptic connections. We're getting less effective with our transmitters. So we're going to see neurotransmitters like dopamine, serotonin, acetylcholine, which play essential roles in our mood regulation, memory, and motor control, naturally just decline over age, which is going to cause a lot of problems for us. Um, Things like serotonin are going to cause symptoms like depression, reduce memory capacity, and motor control with our acetylcholine. And for example, the decline in dopamine is often a major risk factor for Parkinson's disease, which is very common. And is there a way to measure or quantify this degradation? We use MRI scans, more specifically T1 weighted MRI scans. They are the most common type for detecting brain atrophy. These images provide a high contrast between different types of tissues, making it easier to identify the boundaries between gray and white matter, as we saw in that previous slide. There's also a way to quantify it with voxel-based morphometry, or VBM. It's a specialized MRI technique that allows for the quantification of brain volume. It divides the brain into units that they call a voxel, which are kind of like described as pixels on a monitor. It's just a way for them to quantify the actual amount and measure the volume of different brain regions in a more precise way. And then mean diffusivity, or MD, is a measure of water diffusion in the brain tissues that can be used to examine brain structural integrity. It's calculated as the average of the three eigenvalues of the diffusion tensor, which describe diffusion in the different directions. So, on one of my main studies, I found these results as aging occurred. We see as our age is going up, our mean diffusivity is also going to see a proportional growth. It's going to increase over time with age. MD, as the number gets larger, is showing a less productive or efficient white matter. It's meaning that it's letting too much water, or it's not effectively letting the water through. And then over here, it's a little hard to see, but there is a graph based on gray matter with age, and you'll see this steady decline as we get older. That's gonna be what we see as our cognitive decline, as we're losing this much neurons and the connections. Uh, there are some preventative measures we can do to help long or extend our longevity of our brains, such as mental stimulation or learning. Keeping the brain active and engaged is one of the most effective ways to maintain cognitive function as we age. Mental stimulation promotes neuroplasticity. Like I said, we really need to be working on that because we want to use it or lose it. So if you want to keep those, we got to be working on them, reading, doing puzzles, engaging in new hobbies or learning skills. The brain is still able to adapt and form these new connections as we get older. It's just much more challenging for the brain. So we need to challenge it with these new skills to help delay the onset. Exercise, physical activity has been one of the most significant impacts on brain health. It increases blood flow to the brain, which promotes the growth of new neurons and boosts brain-derived neurotrophic factor, or BDNF, a protein that supports the growth and maintenance of neurons. Exercise also helps protect against inflammation and oxidative stress, which contribute greatly to brain aging. Examples of this would just be going for runs, walks, lifting weights, swimming, etc., hiking, whatever you would like to do. Diet also plays a very crucial role in our brain health, as certain nutrients support cognitive function and protect against neurodegeneration. A nutrient-rich diet can reduce inflammation, oxidative stress, and improve blood flow to the brain. Examples of this would be following diets like the Mediterranean diet that are shown to benefit the brain greatly with omega-3 fatty acids, and get enough protein to promote our brain health, and take supplements such as magnesium, for example. And the side effects that we are presented with as our brain is aging, the primary side effect of aging is going to be a cognitive decline. You're going to notice this greatly in older individuals. Memory impairment, for example, is one of the most common effects of brain aging. It is a decline in memory, particularly short-term memory, as it talks about with the hippocampus. It's not going to be able to more effectively uh, process and send out that information for long-term storage. So in older adults, they have difficulty recalling recent events, conversations, or where they placed objects. This is often referred to as age-associated memory impairment, which is generally harmless, but it does somewhat interfere with their lives, just not significantly. You're going to notice a very slow processing speed. Aging leads to slower information processing. This means that it may take longer to solve problems. You're going to see this as the myelination starts to degrade. You're going to lose a lot of that that conductivity and that speed. And you're going to have difficulty with complex tasks. Tasks that involves higher cognitive functions such as planning, problem solving, abstract thinking can become more challenging as the brain ages. This can affect activities like managing finances, navigating technology, or solving complex work-related problems. Um, and aging is considered to be a major risk factor for many neurodegenerative diseases such as Parkinson's and Alzheimer's. This is due to complications that aging presents on the brain. In the case of Parkinson's, the lost regulations of neurotransmitters like dopamine can lead to the development of Parkinson's disease, as we're seeing this loss of synaptic control. You're going to start to see these more serious diseases show up that will just only further demyelinate the brain and shrink that brain matter. And why should we care about this? Aging is something that we're all going to have to experience. We're all going to start to notice these cognitive declines. So we should be thinking about how will this affect you or your loved ones in the future? How will our brains look in the next 60 years? And what can we do to work towards longevity? As I said, there are a lot of preventative measures you can take, like working out, reading, writing, learning new hobbies and skills. It's just a lot of things that you need to do to keep your brain active and healthy. We just need to keep that brain matter strong, keep those axons firing. Um, Especially if you want to look like these old people here taking some selfies. I don't know. I don't know how you guys feel about that. But overall, I just know that personally, I have lost a loved one to Alzheimer's, and it's very sad to see that loss of memory and that cognitive function. It's incredibly hard to watch. As well as I had a neighbor who was diagnosed with Parkinson's when I was really little. Obviously, I don't remember him that well. I was definitely a kid. I was around 8 years old, but just learning how these things are going to affect us and what we should do to prevent them is a big deal, and I think it's important for everyone. And here are my citations. Thank you.